Graphs.
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 I'm the doctor.
What?
So, we're on to graphs and transformation
Yeah.
in Core 2.
That's Unit 2 of Core 2, is what we're doing. That book.
So we've what it does is it asks you a lot of random questions and then gives you this information, but not as good as this.
No, we're putting the information a different way. I think it makes more sense to do it like this.
Yes.
In a lovely table. It's a great table. I like tables.
Harry liked tables.
I liked Harry. Right, so swap places.
We've drawn a cubic here,
We have drawn a cubic.
and these are all functions of graphs.
Yeah.
And these different things do different things to the function, which is what this is all about.
It is.
So the first one, we've got f of x is replaced with f of x plus a. So, I'll give you a pen. Would you like a red one?
I like a red was good.
Okay.
Alright.
What this does, and you've actually met this in Core 1
Did
without
do it in
really
Core
knowing
1.
what you were doing, if you got this and you place it by f of x plus a, it moves everything to the left one, not the
It
way you
does.
would expect it to move.
So that means it moves it by a translation.
Minus a over naught.
Yeah.
And you should remember that when you do vectors with translation, the x is on the top, the y is on the bottom.
You should.
So every value here has moved to the left one.
Not fantastically shown in my drawing.
No. But you can see that this has been moved slightly to the left, this has, and this isn't going through the origin, whereas here it is.
Yeah.
You didn't draw it very well.
I didn't draw it very well. If we move the y-axis here, that's where the y-axis is. Done.
Yes.
Right.
So it's been moved in the x-axis, but nothing's really affected it. The shape of it's the same,
So,
the
yeah.
heights it goes to, it's just moved to the left.
It is
That'd be the same for a quadratic, that'd be the same if it's
a line graph.
a line graph, anything.
Anything, yeah.
Now f of x plus b, you'll notice the plus part isn't in the
It's
bracket.
separate.
That's a different thing.
Yeah, and that means
It's a translation, but in the y
the
direction.
y-axis. So
It moves up. This isn't the opposite.
yeah,
forward
this
thing.
goes because it's out of a bracket. It goes where you think it should.
Yeah. Plus
Here's-
b is actually plus b, upwards too.
So do that as well.
Every point on this graph has been moved up one, so that part, that curve will only just come under. This part will be up a little bit. Sort of like that, yeah. That's a much better one than the first one. I'm impressed with that.
I've learned things.
So this is a movement in the y direction.
It is.
But again, it doesn't affect it, doesn't squash it, doesn't do anything like
Doesn't
that.
do anything like that. So we
And
call
these
it
two-
translation of a zero b.
These two you actually approached at Core 1.
We did. And the rest we didn't.
The rest we didn't. Although
These
you might
we
have touched on them at GCSE.
We might have done a few of them,
if you're a
but
top A-star student.
poses. Right.
So f of x has been replaced by minus f of x, the minus being before the f of x. And what does
Yeah.
that mean?
Well,
A reflection in
it
the
means a
x-axis.
reflection, sort of. Yes, reflection.
So reflection is quite simply turned upside down. Again, it's not squashed, it's not moved to the left or right, it's just reflected and in the x direction, so like this. So this
Right.
bump will
Should be
be
here.
underneath, this bump will be on the top, and yeah, exactly like that. That is
Yeah.
really good.
Yes.
I'm really impressed.
Oh,
Well done, Triv.
thank you.
Pat on the back.
Right.
F minus x, when the minus is inside, is the opposite reflection in the y-axis. So everything's been flipped again, but in the y way, so like that. So this whole thing will be on this side, and then this line going up will be on the other side.
Yeah.
Do you want me to draw it, Triv?
I do.
I'm not very good at drawing either, though. So, this goes down through the origin. That should be higher, but
Yeah.
you can see it's
You get the idea.
like that.
Yeah, okay. Sure.
Now we're finally down to here. F of x has been replaced by f of kx. Well, k can be any number, normally 2 or 3 or 4 in the exam, they don't go
It
ridiculous.
ain't go crazy, and this means stuff stretches and contorts and does crazy things
In the x-axis.
in the x-axis.
But again, like this one, it's not quite how you'd think. It doesn't stretch k amount of times, it actually stretches 1 over k amount of times.
Which actually means it's sort of compacted.
Yeah, it gets
Stretches
squashed in the
inwards. So
x-axis.
stretch isn't a very good word, but it is the word you need to use.
Yes. So basically every x value on the graph will be divided by k, so it will all be squashed in. So
Right.
it will look like that,
Yeah.
all squashed in.
But the y values will be the same, so look at the same heights. And
Yes, so this
stuff.
point here
It's the same as that point
will
there.
be the same, except the x will be k times smaller.
It would be.
And as you can imagine, because they're all opposite to each other, the last one, f of x, k f of x, so the k's before,
Yep.
stretch,
in the
stay
y
off
direction.
to k. So this one isn't confusing like this one.
No,
this
it's
is exactly as you think.
That basically means everything's just
Ballooned up, got bigger,
Taller.
really tall. Like that. And again, the x values would actually stay the same.
they would.
And
And,
well, drawings here aren't fantastic, but you can see sort of what we do.
yeah. This is pretty
did a
much.
pretty good job. It's a pretty good job there.
Yeah. This is pretty much the introduction. Later on, you have to actually find out what these terms are and then draw them accurately.
Yes, but it's easier to plot when you've got
When you've got
proper
graph paper as opposed to a big board.
That's what they give you in the exam.
Yeah.
But this is a whole new topic. It's all about transformations. They give you the questions, then give you this information in the book. We've given you this information. Now I
They
think
give
you
you
can pretty much
questions.
go straight to test yourself now, the proper question.
You reckon?
I reckon. There's not,
Alright.
there's not much more to learn.
Okay. Well, let's crack on with that then.
Thanks, Harry. Alright, test yourself, page 29, question 1 and question 7 of this book.
Ooh. Alright, so here's a penguin.
Right.
So question 1 for part A is describe the translation that will map 1 over x onto, I meant y. Y equals 1 over x plus 5.
Okay.
So what's going to happen? So Wayne's going to write it out, and I'll talk you through it.
Alright.
So it says describe the translation. So we've got to think back to our table. It's like having a bracket here. It was x plus something, which means it needs to be a translation. And because it's plus and it's inside the bracket, it's a minus. So it moves the entire thing minus 5 in the x direction.
Yeah.
Yeah. Then part B
Part B, I need the black pen, I need the black pen, I need the
Oh,
black pen, I need the black pen. B.
is sketch this graph.
Oh, well, first I'm going to sketch the other one, I reckon.
Okay. So we're sketching the first one. 1 over x. This is one of the graphs that you need to know. Top of your head, I won't tell you this one. There's a few graphs like this. We might go through it in the summary. And it looks like this. That's what it looks like. It's very nice. That's what like is. Yeah. And here, it's this centre point here is minus 5 because that's the centre point in the original equation. That's all been moved. Now finally, part C, just what the equation, well, this vertical asymptote. That's the only thing that wasn't on our table. The asymptote is something where the graph won't work, it's something that nothing will encounter. Like if you put minus 5, which is the equation of the asymptote, into here, it would give 1 over 0, which doesn't work. And that's how you can define asymptote, I guess.
And because these go like this in this particular shape, they will merge closer and closer to the asymptote but never touch it.
They'll
That's
never
what
touch
really
it.
is.
That's what it really means, yeah.
We didn't talk about that before.
Yeah.
So what was the question, just to state what it is?
Yeah, what is the equation of the
X
vertical
equals
asymptote?
minus 5 in this case.
Yeah, that's that.
Because at minus 5 this won't work.
Yeah.
It's
Now,
that simple. But yep.
on to question 7.
Question 7. We're going to need a board, rather.
Yeah, it's down there.
So where? Oh, I see
there it is.
Take
Found
the
it.
book, take the
I'll
book.
take the book. Okay.
Done.
Right. Okay.
I'll take the book.
Take the book. I'll take the back.
Let's swap.
Alright, so let's do this.
Question
Okay.
7a, part 1.
Right.
Okay, the diagram shows the graph of y equals f of x. It has a rotation of symmetry about 0, 0. I'll show Triv the picture.
Okay.
Sketch on separate diagrams the following graphs. Y equals f of 2x.
Oh goodness. Okay, first I'll draw the original graph. That pen is dead.
There's another black pen here.
Okay.
So, it looks like this. Minus 4.
That's minus 4.
This is 2. The bottom's minus 2.
And that's 4.
And it's 4. That is y equals f of x. So the question
Okay.
says, sketch on a separate diagram the following graphs. Part 1 is y equals f of 2x.
Sketch. Y equals.
F of 2x.
Oh. Okay, and Wayne's going to talk us through it.
Yes.
I'll do it.
So, from your rules that we did just a little while ago, which we had the big table about, because it's inside the bracket, it's 2 lots of x. It's a stretch, scale factor 1/2 in the x direction. So all of these coordinates of x are in fact half, and it's essentially squashed in the x direction. But, so this will be halved to -2, this will be halved to 2, but these points will still be the same. And it is that simple. It's a stretch, but except it's a squash, but it's still called a stretch in the x direction. Scale factor 1/2. Now part 2 is again another sketch on a different graph. Y equals 2 lots of f of x. Again, from our rules we had a second ago in the table, this is another stretch, except this time it's in the y direction, and it's not opposite to what you'd think. It stretches it 2 times in the y direction. Essentially it will go up twice as high and down twice as low. The x's stay the same, so it would be -4 and 4. It would go up to 4 and -4 at the bottom.
Okay.
Now part B is
Black pen.
black pen. Describe the transformation that maps the graph of y equals f of x onto the graph of y equals f of 2x, which is this one that we did. So describe that. And in the exam it will actually come up with questions just like this for 1, maybe 2 marks, where you've got to say the transformation and then some numbers. So it says describe the transformation that maps the graph of y equals f of x onto the graph of y equals f of 2x. So you have to say it's a stretch, that would be 1 mark, by scale factor 1/2. It's the opposite to what you'd think. It's not 2, it's 1/2. And then in the x direction. Now they're quite mean in the exam. Often you've got to say scale factor 1/2 in the x direction to get just 1 mark. Those 2 marking points for 1 mark. So that was number 7. You did quite well.
Yeah, did all that. That's pretty much the sort of thing you're going to get in the exam.
Yep.
It's more or less it. It's quite an easy chapter really. Again, it's another building block.
Yes.
Get it a lot more later.
This comes up a lot in trigonometry especially.
Yeah.
But it will be brought back in core 3 and core 4.
Something to look forward to.
So I think we should sum up the video. We'll talk about properly what we've done today.
Yeah, so asymptote time?
Asymptote.
Summary time.
Alright, so
Yeah. So we did
core 2.
part 2.
Transformation.
Yeah, all the graph stuff. It's quite a small unit as well, that one.
Yeah, it's literally once you've learnt that table, you can do this this unit. It's fine.
Yeah.
Once you've learnt that.
Once you understand what an asymptote is, that we said before, there's a part where the graph doesn't exist.
Yeah, and it comes up more in trigonometry.
It
We were
does.
just talking about this before we pressed play. When does it actually come up in the actual papers?
It's normally, almost certainly it's going to be entwined with trigonometry. It's very rarely.
It's not a
anywhere
question
else.
on its own.
No.
It's just not big enough.
It's not big enough.
So it's normally we'll get on to trigonometry. That's the next chapter, in fact. But when it's that, it will then give you some stuff and say it's been transformed. What transformation is it and stuff like that.
Yeah.
Literally what we did in the test yourself. Nothing harder, really.
Nothing harder. You just need to know all the stuff. There's a few bits you can get confused with, like the stretch. When it's through the x direction, it's actually 1 over what it says in the bracket.
I'm just drawing a few graphs. That
Oh
they
yeah,
have
there's
to
also
know.
a few graphs that come up and they just assume you know. So you should really. There was one we covered in the built video, it was y equals 1 over x, and
This
that's
one's over here.
this one here.
Y equals 1 over x.
You
Up
be-
here we've got y equals x squared.
Yeah, you need to be familiar with cubics as well.
Y equals x cubed. It looks like that. That's the simplest one.
Yeah, these are simple versions of something else. And there's one other graph, which is y equals square root of x.
I'll move out the way. Looks like that.
Yeah.
It never touches.
It touches the x-axis and it gets quite high.
It gets very big.
Yeah, and they might ask you to play around with these graphs.
Yeah.
Like we used before. That's pretty much it.
Yeah. I think we've pretty much summed up Unit 2. Well, Chapter 2.
Chapter 2.
Yeah.
Yeah, so next on to the next video.
In fact, yeah.
Yeah, let's do it.